So dividing complex numbers. Um, we're going to take this and we're going to write the quotient in the form a plus bi. So again, this is standard form for writing these, where we write the constant first and then the imaginary term second. So when we have denominators, they have to be rational numbers. So we can't have I, an imaginary number, in the denominator. It has to be some kind of integer rational number so that we can actually divide. So for imaginary numbers, we have to multiply by a power of I in order to make the denominator simple. So a reminder, I is the square root of negative 1. I squared is equal to negative 1. So this, if we can make our denominator have an I squared, we can change it now to a number, an integer, and that'll change our problem. So we have 8 divided by I. So, well, this one's kind of easy. All we have to do is multiply by I. Same on top and bottom. We get 8I divided by I squared. Based on definition, I squared is negative 1. So 8I divided by negative 1. So the answer is just negative 8I. Now, our denominator's a rational number, so we're good to go. And now let's do another one that's a little more complicated. So direction is the same. We want to write this in standard form, a plus bi. So we want to make sure that when we're done, we have our constant term, and then whatever our coefficient is for the imaginary terms, second. Now this is a fraction with a binomial denominator. So when you have denominators with binomials, you multiply by the conjugates. So all the directions are here. We did the same thing for dividing radical expressions. So the conjugate in this case, if our denominator is 8 minus 2i, we're going to multiply by 8 plus 2i. We're going to do that on the bottom. We're going to do that on top. And since our original problem, 3 minus I over 8 minus 2i, are both binomials, we want to use parentheses so that we can distribute those expressions. So our numerator, 3 times 8, 3 times 2i, and then we're going to have negative I times 8 and negative I times 2i. So that gives us 24 plus 6i minus 8i minus 2i squared. 24 minus 2i, and remember this I squared over here is actually negative 1. So this is 2 times negative 1, which really changes that to plus 2. 24 minus 2i plus 2. Our numerator is going to be 26 minus 2i. So that's our numerical expression just for the top of our fraction. So now we can do the denominator and see where this leads us. So our denominator is going to be 8 minus 2i times 8 plus 2i. These are conjugates. When you multiply conjugates, they have a trick. You get a squared minus b squared. So this is going to be 8 times 8, which is 64, minus 2 times 2 is 4. I times I is I squared. So same situation here with the I squared. That changes to a negative 1. Negative 4 times negative 1. That changes to a plus 4. 64 plus 4 is 68. And that is our denominator. numerator, denominator. Let's put them together. 26 minus 2I over 68. These are all even numbers. So I'm going to divide the entire numerator and the entire denominator by 2 to simplify this. 13 minus I divided by 34. Now this is typically how we write fractions, but the correct way to write this answer in standard form is to separate them into two separate pieces, which means this should be written as 13 over 34 as the A value. And then this B value should really be negative 1 over 34 times I. So this is how you would write the answer. The other form is equivalent, but you always want to be prepared to write them in different ways depending on the questions you're given.